Yeah, hello students. In the previous videos I have done around 8 DPPs. I have done daily practice problems around 70 to 80 problems. Now I'm going to do another 10 problems in DPP-9. You can see f of x equal to 0 takes log of t plus root of m plus t square dt is even function, even or odd function, periodic function. When they're talking about even function or odd function, you know that f of minus x equal to minus f of x odd function. F of minus x equal to f of x even function. Periodic function. F of x plus p is equal to f of x, where p is the least positive integer. F of x is periodic function with period p. You should familiar with periodic function and odd function and even function. When they give you like this, for example, I have taken f of t equal to log of t plus root of 1 plus t square. So remember this one, whenever f of t is odd, suppose f of t is odd function, f of t is odd function, then integral 0 to x f of t is even function. This will be even, always remember. Whenever f of t is odd, integral 0 to x f of t is even. But here you can see f of t log of t plus 1 plus t square. This is odd function. Replace t with minus t, rationalize it. It gives minus log of this f of minus t equal to minus f of t. This function is odd function. Since this function is odd function, so this entire problem is even function. So your answer is even function. Even function. You can verify this, whether how it is odd, you can verify that. You can check that f of minus t. If you take log of minus t, you will get 1 plus t square. Just I'm giving an idea how to prove that the function is odd. So if you rationalize this, if you rationalize with the rationalizing factor, you will get this one rationalizing factor here. You will get root of 1 plus t square. You are rationalizing with root of 1 plus t square plus t. You get minus t square. Or after rationalizing this, you will get 1 plus t square. This one cancel this one. You will get log of t plus root of 1 plus t square whole power minus 1. You will get minus again hold here minus log of this minus f of t. So f of minus t equal to minus f of t. So this is odd function. So that is the reason integral 0 to x f of t and f of t dt. So f of t dt, this is even function. Integral 0 to t f of 0 to x f of t is even. When f of t is odd, 0 to x f of t dt is even function. Same way, this is odd function. So 0 to x f of t dt is even function. Now see, in this problem they are given integral ln lambda ln of 1 by lambda f of x square by 3 f of x plus f of minus x by g of 3x square g of x minus g of minus x dx lambda greater than 1. Since you can check that ln lambda, we have the limits like this. Ln lambda, ln of 1 by lambda means minus ln lambda. Correct. Lambda over minus 1. Like integral a to minus a. So if I give a to minus a, I will take this one, let it be h of x dx. Let it be h of x dx. I will take h of x dx. Because here like a to minus a, minus a to a, better you verify whether the given function is even or odd. So since a to minus a, minus a to a, so I will verify that if this is h of x you have taken. You have taken the function is h of x. Then you take h of minus x. If you take h of minus x, f of x square by 3, no change. F of minus x, f of x, replace x with minus x. Then g of 3x square and this one g of minus x minus g of x. Just replace x with minus x. Then you take minus common here. So minus f of x square by 3. You will get x square by 3. This is f of x plus f of minus x by, I have taken minus, you take minus common, I have taken. So g of 3x square into g of x minus g of minus x. So this is minus h of x. That means this is an odd function, right? h of minus x equal to minus h of x, so h of x is odd function. When the function is odd, the answer is 0, right? So the function is odd, the answer is 0. We'll do the next one now. So in this problem, they are given integral 1 by 2 to mod log x based on dx. This one I can write. Mod log x based on, we can split that log x base e into log e base 10. I can split this 1 by 2 to 2 dx. But here log e base 10 constant, I can take it out. Log e base 10. But mod log x base e between 1 by 2 to 2. At 1 that will be 0. So I can split this. I can split this integral 1 by 2 to 1 minus log x base e dx. I will write 1 to 2 log x dx. When I have taken common, you will get mod log x base e. At 1 that will be 0. 1 by 2 to 1, 1 to 2 split that. But we know that integral log x, always remember, integral log x dx, x log x minus x, x log x minus x. If we use that concept here, so this is the expression into log x dx, x log x minus x. So this will become now minus log x base e minus x log x plus x limits 1 by 2 to 1 plus into log x log x minus x limits 1 to 2. Now you can simplify. Again at log e base 10 upper limit, this will be 0, upper minus 1 log 1 0, you will get 1 minus lower limit plus 1 by 2 log 1 by 2 minus 1 by 2, upper limit minus lower limit, we substitute this minus 1 by 2 minus 1 by 2 is the same thing. We apply upper limit 2 log 2 minus 2, lower limit minus 1 0 minus of minus plus 1, so this 1 and 1 cancel with minus 2. Set that log 1 by 2 minus of log 2 plus 2 log 2. So you will get log e base 10. This is of log 2 power minus 1 minus of log 2 2 log 2. 2 minus 1 by 2 3 by 2 log 2. If we combine these two, 3 by 2 log 2 minus 1 by 2. So I can write this one. To 1 by 2 can take it common, 1 by 2 log e base 10. 3 log 2 is log 2 cube. Minus, I have taken common 1 means I can write this will be 1. I can write log, this is log 2 cube log 8. Log e base e I can write here. So you can see here 1 by 2 log e base 10. This will become log 8 by e. Because 1 is log e base e, I can write log of 8 by e. Log e base 10 base e. This is base e I have written. Because log e base I can consider. Consider as base e. Log 2. These are all with base e only I am doing here. Base e only. If you take this one, again same thing, the answer it comes now. Finally you will get 1 by 2 log of 8 by 8, log e base 10 into log 8 by e base e will be log of 8 by e base 10. Your answer is second option. Your answer should be second option. Just be careful here. There's multiple. The product of this should be log of 8 by e base 10. The answer should be second option. This is important model. Do it again. One more time, do it. Now see in this problem, they are given integral 0 to 100 sin of x minus step x pi dx. But x minus step x is nothing but always remember x minus step x gives fractional part of x. So the period of this is 1, right? The period of fractional part of x is 1. Since the period is 1 here, this I can write 100 into 1. This problem 0 to 100 into 1, because the fractional part of x is 1. 100 into 1. Sine of fractional part of x, pi dx. So here the property equals 0 to n a, where a is the period of this function, n into. This is the property equals 0 to n a, f of x dx. If the period is a, if the period is equal to a, I can write n into 0 to a, f of x dx. When the period of this function is n into 0 to a. Say I can write here 100 into 0 to 1 sine, between 0 to 1 I can write sine fraction part of x pi dx. So between 0 to, you can consider between 0 to 1 fraction part of x, this will be x only, right? It will get be x. Since the 0 to 1, x only, x pi. So sine x pi means you will get 100 into, you will get integral of sine of x pi means cos x pi. You will get 0 to 1. I can apply the limits. Integral sine minus cos x pi, minus cos x pi, minus 100 and by pi. Correct. Now I am saying here integral of sine x, because 0 to 1 integral fractional part of x is x only, x pi. Sine x pi is minus cos x pi by pi, limit 0 to 1. If we substitute this minus 100 by pi, cos, this is a substitute cos pi minus 1, this is minus 1, you will get 200 by pi. So this is your required answer, 200 by pi. Concept is important. Learn all this. It helps to solve any one of the problem. This concept is important. Now we do the next one now. Here they are given minus 2 pi to 2 pi cos 466 dx. So when they are given minus 2 pi to 2 pi, you can verify whether the function is even or odd. Check that the function is even or odd. Really we know that replace x with minus x. Cos of minus x whole power 6. We will get cos of minus cos x only, cos 466. So we got the function is even function. Since the function is even, I can write this one 2 into 0 to 2 pi cos 466 dx. Again after that I can also verify. If we replace x with 2 pi minus x, we get the same function, right? Cos of, you replace x with 2 pi minus x. Cos of 2 pi minus x, it will be cos x only. When it gives cos of 2 pi minus x cos x, we have another property. This I can write 2 into this 2 into half of this I can write 0 to pi cos 466 dx. Right? Again you can say the same property, replace x with pi minus x, x with pi minus x. So x with pi minus x. Then sorry, I am replacing x with pi minus x, cos of pi minus x. This is power 6 only here, cos power 6. I can write this will be cos power 6x only, no change. Here also this is cos power 6, replacing pi minus x. Minus cos x whole power 6 becomes cos power 6x. We get the same result. Again using the same property, half of this I can consider. You get this is 4 into 2 into 0 to pi by 2 property. If we use the property, whenever replace x with pi minus x, if it gives the same function, you write 2 into 0 to half of this. So cos power 6x dx. Now 8 into, I can use reduction formula, Wallis formula, I can use it. So what is Wallis formula? 0 to pi into cos power 6x. I can hit 6, reduce 1, 5, 4, 3, 2, 1. You can write it 6, 5, 4, 3, 2, 1. Since whenever half into pi by 2. Suppose ending fraction is 2 by 3 into 1. Like this, if we get like this. Now, if we get like 3 by 4, 1 by 2 into pi by 2. Now you simplify this. 8 and 3 2's. Answer is 5 pi by 4. We get this 5 pi by 4. Here so many concepts included. Try to practice this type of problem. It helps to solve any other type of problem related to this. So in this problem, they are asking limit extends to 0 x power 4 by integral 0 to x square tan inverse t dt. When applying 0 here, we will get 0 by 0 form. Replace x with 0, we get 0 by 0 form. If we get 0 by 0 form, we use the L'Hospital rule. L'Hospital derivative of numerator by derivative of denominator. If we take limit extends to 0, derivative of numerator is 4x cube. Now use Leibniz rule. Derivative of this integral, use Leibniz rule. What is the Leibniz rule? Replace t with x square, tan inverse of x square, into derivative of x square is 2x. Derivative of x square is 2x. Derivative of x square 2x minus replace t with 0. Tan was 0 into derivative of 0. So that's the reason that we can eliminate. So Leibniz rule. You know the Leibniz rule. You should apply the Leibniz rule. So replace tan inverse of t with x square, derivative of 2x minus tan inverse of 0 into derivative of 0. 0 it will be. So we get like this. Now you can see here. This will be x square and here this is 2. We will get this one 2x square. So I can write this one 2, I can take it outside. This 2 into limit extends to 0. I can write this problem. You will get x square by tan inverse of x square. Tan inverse of x square. So this will be 1. We know that x square tan inverse of x square is 1. Why? Because limit extends to 0. Tan inverse x by x is equal to 1. Even if you want, I can write this one 2 into, I can also write limit extends to 0. Tan inverse of x square by x square we can write. So this is 1. So 2 by 1. Your answer is 2. Your answer is 2. This is by x square. We do the next one now. Now here, always remember this one limit sum, but we can write in terms of definite integral. Definite integral is a limit of sum. We should use that concept. For that, what we do here, limit n tends to infinity. You can write 1 by n, 1 by n plus 1, 1 by n plus 2, and so on. This I can write 1 by n plus 2n. So we have almost, you can see here, this is the terms. We have n, n plus 1, n plus 2, n plus 2, n 3n. So we have the terms from total, we have n plus 1 terms here. N value 0 to 2n I can consider. N value 0 to 2n. I can write this limit n tends to infinity. Limit n tends to infinity. Now if we take the values of this, I can write here directly n plus 2n. I can, all the values we can write. If I write sigma, I can write sigma r equal to 0 to, I can write n, r equal to 0 to 1 by n plus r I can write. So 2n, 0 to 2n I can write, r equal to 0 to 2n, right? Sigma r equal to 0 to 2n because n plus 0, n plus 1. We have 2n plus 1 term, 0 to 2n, 1 by n plus r. Now, I can take it n common here, limit n tends to infinity, to take it out n common, 1 by n, sigma r equal to 0 to 2n, 1 by 1 plus r by n. So this is the, like this I can convert it to definite integral. So 1 by n, r equal to 0 to 2n, 1 by 1 plus r by n, which is equal to integral 0 to. So when the coefficient of n is 2 here, coefficient of n is 2, then it will 0 to 2. If the coefficient of n is 1, 0 to 1, integral 0 to 2, I can get 1 by 1 plus, replace r by n with x. Now that you can see 1 by 1 plus x, it is like 1 by t. Derivative of 1 plus x is 1. When the derivative of 1 plus x is 1, in integral f dash x by f of x dx, You remember integral f dash x by f of x dx log mod f of x. Log mod f of x, right? I can write log mod f of x. Log mod f of x, right? Log mod f of x plus c. Same thing, derivative of 1 plus x is 1. So I can write here this one value, I can write 2 into log mod 1 plus x. Log mod 1 plus x limits, I can write 0 to 2. So not 2 into this one, I can write only this. Not 2 into, sorry, only 0 to 1 by 1 plus x. You can follow this formula, log mod f of x. So I can get log mod f of x, right? Just I have written log mod f of x. So log mod 1 plus x, 0 to 2. The derivative of 1 plus x is 1 only. Then we get here, applying the limits, log 3 minus log 1. You will get log 3. Your answer is log 3. So this is your answer. Answer is log 3. You get log 3 minus 1. Answer is log 3. Log 3 minus log 1. Log 1 will be 0. Answer is log 3.